Alright guys, so for the next part, for each graph below, find the value of the key features, write your answers in the blanks and space below. So to go over the stuff quickly, domain is your x values of your function. So like this point here is technically, and I'm going to write it out, is 2, 1, so the x value here is 2. So in this particular case, going towards in this direction, you always have an x value somewhere. So as it goes to the left, it's always going to have an x value, so the left part would be negative infinity. Now to the right, it's always going to have an x value somewhere. So as it goes to the right, it's hitting positive infinity. So the domain of this function is negative infinity to infinity. So during the first chapter, one thing we talked about was the concept of either a parentheses or a bracket. If it's doesn't touch or it's infinity, you will always use a parentheses. For range is the y values of the function. So the lowest point of this graph is at 2, 1. So 1 is the lowest this graph will ever touch as far as the y's values are concerned. So we would start a range at 1, and since it actually does touch the 1, we would actually use a bracket in this case. Since no matter what, as we go up forever, you should have a y value, the range of this function would go up, and since these numbers are getting bigger, they're going towards positive infinity. So the range of this function would be 1 to infinity. Parentheses on the infinity, and bracket on the 1. The minimum, however, is the smallest part on the graph. And you had absolute minimums and you had relative minimums. On this particular graph, the smallest it ever hits is 2, 1. So you have a min at 2, 1, and since it never ever goes lower, this would be absolute. For the maximum, it is going up forever. It has no stoppage, so this one is not available, does not exist. Now, one thing we did discuss earlier was in behavior, and we talked about is it going to the left and is it going to the right. So since this graph is technically going to the left forever, as it's going to the left, which is negative infinity, the y values are getting bigger in this direction. So as x is approaching negative infinity, y is approaching infinity. On the flip side, as this graph is going to the right, x is approaching infinity, the y values are also going up. So in this particular case, y is approaching positive infinity. Now just in case later it happens, if the graph was going down, the y would be going to negative infinity. So looking at this next particular problem, as far as the domain is concerned, since there's an arrow in both directions, this graph is going to the left forever. This graph is also going to the right forever. So the domain of this function would also be negative infinity to positive infinity. So let's look at some y values. This coordinate here is technically 1, 0. This coordinate here is negative 2, 0. Now, we're not worried about the x values, but both of these are 0. It does not go any smaller, so the beginning of a range would start at the number 0. And since it actually does touch there, we would have a bracket. The range of this function goes to 0, goes up forever, so the range of this function would be 0 to positive infinity. Now this problem has two mins. Since these are on the lowest part of the graph in both parts, your two mins are the point negative 2, 0, and the other point is 1, 0. These are both absolute mins. I'm just too lazy to write the word absolute. But this time, we actually do have a max, and the max here is at this weird point at 0.5, negative 0.5, comma 5.063. This is not the absolute highest point of the graph, but at this point in its existence, it is the highest point of the graph. This is what we call a relative max. Now, this graph is similar to this graph when it comes to end behavior. As this graph is going to the left to negative infinity, the y values are going up. So it'd be x is to negative infinity, y is to positive infinity. As this graph goes to the right, which we would call positive infinity, the y value is going up to infinity. And that is how you figure out end behavior on graphs. And now we're moving on to the next video.